Here we have the triangle inequality theorem. I'm going to do an intuitive proof of why this is true. So basically it says that the sum of any two side lengths in a triangle is going to be greater than the length of the third side. So the sum of these two lengths. So let's see what we have. So let's say I have two side lengths. Let's say I have this side length, and then let's say I have some other side length. Oh, wait. I have one side length, and then let's say I have some other side length here. And basically, you want to imagine all the possible third sides. So, oh, wait, again, same problem. There we go. And yeah, you want to imagine all the possible third sides. So this is a possible third side, that blue length right there. But you want to remember now, these two side lengths, right? This side length right here, this green side, let's call it side A. This is A. And then now this orange side is side B. And you want to imagine how you could swing A or B. It doesn't matter, but just changing this angle, right, is going to give you all the possible triangles that you could have with side length A and side length B. They meet at this vertex right here. And if you imagine that, right, I could take B and I could swing it, maybe to over here, right? But if I do this so it lines up perfectly, then that's not a triangle. But I could swing B to maybe right here, right? And I'm trying to make it accurate to the length of what B is, And if you see, there's one triangle right here. Let's draw the third side. So there's one triangle here, right? Then there's another triangle here, perhaps, right? And then there's another triangle maybe right there. But eventually it's going to overlap perfectly. And when it overlaps perfectly, that length is going to be whatever A is plus whatever B is. So that blue length you should see is getting stretched out as I move. That blue length, this side C, the final side, right? That final side is getting stretched until it's going to be too much. It's going to just perfectly overlap right onto the straight line, and that's not possible. So the max for that remaining side, it cannot be equal to A plus B. It has to be less than this last side. So we could state it as, for any two side lengths, A plus B always has to be greater than the third side, C. And that's an intuitive proof, okay? That follows intuition. All right, if you understand this, then you're fine. You understand how it is that this theorem is true. Now let's use this theorem. So how could we use this theorem? I could say, does a triangle exist with side lengths 5, 5, 7? So can I build a triangle with side lengths 5, 5, and 7? Well, let's see. Is it true that the sum of any two sides is greater than the third side? Well, is 5 plus 5, is that greater than 7? Yep. And that's really the only one you need to check, because 5 and 5 are the lower two sides. You could check 5 plus 7 is, of course, greater than 5, and 5 plus the other 7 is greater than 5. So this is good. Yes, you could have a triangle with those side lengths. But could you have a triangle with side lengths 2, 4, 1? Well, let's see. Is it true that the sum of any two sides is greater than the third side? So 2 plus 1, is that greater than 4? These are two side lengths, 2 and side length 1. Right? Is that greater than 4? No, 3 is not greater than 4, and then this triangle cannot happen. For the reason, if you want like a good understanding, if you have a side length of length 2 and then a side length of length 1, it doesn't matter how you move these two sides together. This resulting length will always be less than 3, right? Because this length is 1, right? If I move this in a way so I get 2 here and then 1 over here, 2, 1, then this is not greater. This is 3, and I can't have a triangle in this situation. But if I move the 1 over to here, right, then I can have the triangle right here, but this length, this resulting side here is not greater than 3, and it'll always be less than 3, because this length is 3. Anyways, okay, that's one question I could ask you. I could ask you, does a triangle? This is no, and then this one was yes. But the last thing I could ask you is I could give you two sides. So I could say, take two sides let's say, I don't know, 1 and 4. And then I want you to come up with a range of the possible third sides. So let's call that third side x. What's the possible range for third sides x? Well, I need it that 1 plus 4 is greater than x for sure. I need it that the sum of these two sides is greater, and I'm just going to write it like this, it's a little bit easier. It's greater than x. 1 plus 4 is 5, or x is less than the sum of the other two sides is the same way of stating this theorem, right? You could say uh, for any side length, right, any side length is less than the sum of the other two side lengths. That's the same exact theorem, the triangle inequality theorem, but just stated slightly different. So in this case, I have, right, these two, the sum of these two needs to be greater than this, greater than x. So x needs to be less than the sum, right? So x needs to be less than the sum. But simultaneously, you need to look at these three sides, and you need to say, well, it's also true that whatever this side, whatever x is, plus 1 needs to be greater than 4, right? This is the sum of two sides, so it needs to be greater than the third side, where the two sides that I'm talking about are now x and 1. And if you minus 1 on both sides of this inequality, you get that x has to be strictly greater than 3. And you could say that as x is greater than 3. And this gives you a possible range for the side lengths of x. You could have said it's true that x plus 4 needs to be greater than 1 as well, but this gives you a redundant piece of information. This gives you that x needs to be greater than negative 3, which is of course true. X needs to be greater than it has to be 0 or positive. I mean, x has to be a positive number for this to be a triangle at all. So this is redundant information. But if you do x and then the lower side between these two, x plus the lower side has to be greater than the greater one between the two that I give you, then you get relevant information. You get information saying x needs to be greater than 3. Because if, let's say, x is less than 3, let's say x is 2, right? That triangle won't exist, right? Because 1 plus 2, is that greater than 4? No. So the sum of two sides, is it always greater than the third side in 1, 4, and 2? No. And that's exactly the triangle we had here. But okay, this is the triangle inequality theorem, and these are the two questions I could ask you: whether the triangle exists, and then the range of the possible sides. So your answer for this one would just be this here.